All right, let's look at our solving equations day number 2. These equations are a little tricky, just a heads up, so please pay very close attention to your PCVNA technique, which we've been using since Algebra 1. Today's learning target is I can solve an equation by applying the PCVNA technique. Step 1 is your parentheses you get rid of by distributing. C stands for combine like terms, one side at a time. V stands for variables on one side of your equal. N stands for numbers on one side of your equal. And A stands for get rid of the attached number to your x or variable by dividing. So let's look at the first one. So we're going to solve each of the following equations for x, so we have a few. And let's see how it works. So we're going to rewrite PCVNA. So PCVNA. We have to ask ourselves, do we parentheses? We do not. Can we combine 3x and 5? Nope. Can we combine 26? Nope. Are our variables on one side? Yes, they are. All my x's are here. Are my numbers on the other side? And they are not. I need to get this 5 over here. So I have to ask myself, how do I get rid of a plus 5? Well, it's easy. I subtract 5. So I get 3x equals 26 minus 5 is 21. And now all my numbers are on one side. Now I get rid of the number attached to my x by dividing. So I'm going to divide both sides of my equation by 3. And I get x is equal to 7. And that's my final answer. Now let's go on to our next one. 8x minus 7 equals 4x minus 5. So PCVNA, no parentheses, can't combine like terms. My variables are not on one side. If I look, I have an x here and an x here. So I need to figure out how to get my x's on one side. I like my x's on the left, so I'm actually going to move my 4x. And if I look, my 4x is positive, so I have to ask myself, how do I get rid of a plus 4x? I'm going to subtract 4x. So subtract 4x, subtract 4x. 8x minus 4x is 4x, and that's equal to negative 5. So I have 4x minus 7 equals negative 5. Now I have to ask myself, how do I get those numbers on the right-hand side? So I'm going to add 7 to both sides of my equation, and I get 4x equals negative 5 plus 7 is a positive 2. Now I ask myself, how do I get rid of that 4 attached to my x? Well, it's easy. I'm going to divide. So divide by 4, 1 second. And if I type that into my calculator, I get 1/2 or 0.5. So 1/2 is my final answer. C, I have x plus 8 divided by 2 equals negative 6. If we think about this, we want to get rid of a divide by 2. So I'm going to multiply 2 to both sides of my equation. So my 2's cancel. So I get x plus 8 equals negative 12. Now it becomes a one-stepper. How do I get rid of my plus 8? I subtract 8. The whole goal is to get the x term by itself. So I get negative 20, because negative 12 minus 8 is negative 20. D looks a little tricky. So let's use PCVNA. Do I have parentheses? Yes, I do. So I'm going to distribute. So I have 6x plus 24. Distribute a negative 2 now, so I have minus 2x plus 2, because negative 2 times negative 1 is a positive 2, and that's equal to 2x plus 20. Now I have to ask myself if I can combine like terms, and I can. 6x minus 2x is 4x. 24 plus 2 is 26, and that's equal to 2x plus 20. Now, are all my variables on one side? They are not, so I am going to move this x term to the left. So I'm going to subtract 2x from both sides of my equation. So I get 2x plus 26 equals 20. Now I want to get the numbers on the other side, so I'm going to subtract 26 from both sides of my equation because it's currently positive. So I get 2x equals negative 6, and now I divide by 2. Divide by 2, divide by 2, and I get x is equal to negative 3. And that's my final answer. Let's go on to our next problem. So in this one, I have 5 times x minus 3 divided by 2 minus 1 equals 14. We want to get this by itself. So we have to ask ourselves, how do we get rid of subtract 1? We add 1, so I'm going to add 1, cancel. I get 5 times x minus 3 divided by 2 equals 15. Now I need to ask myself, how do I get rid of that divide by 2? And that's by multiplying by 2. So this cancels, and then this goes over here. 15 times 2 is 30. So I get 5 times x minus 3 equals 30. I still have parentheses, so I'm going to distribute. So 5x minus 15 equals 30. How do I get rid of a subtract 15? I add 15. So I get 5x equals 45. And then I ask myself, how do I get rid of that multiply by 5? I divide by 5. So I get x is equal to 9. And that's the front of this handout. However, there's going to be a few instances in Algebra 2 where we get some weird answers, and I'm going to go over those cases right now. So we call them inconsistent. So that's when we get no solution. So like we get two different things on the equal sign. So we get like say 3 equals 2, so no solution. And then there are times where we get something called an identity. That's when we get the same thing on each side of the equal sign. So like for instance, we can get like 3 equals 3. What that means is there's an infinite amount of solutions. So any number works. So let's look at these two examples. One of them is an identity and one of them is inconsistent, meaning no solution. So let's look to see how this would play out in our class. All right, so first thing we're going to do is we're going to do our PCVNA procedure. So I do PCVNA, and there are parentheses, so I am going to distribute, and I'm going to distribute a negative 2. So I have 6x minus 2x minus 8 equals, distribute the 3 now, so I have 3x plus 6 plus x minus 5. I'm going to combine like terms. So 6x minus 2x gives me a 4x, so I have 4x minus 8 equals, combine your 3x with an x, gives you 4x. Now do 6 minus 5. 6 minus 5 is a 1. So I have 4x plus 1. I like to move my x's first, so I'm just going to move this x over here. So I'm going to subtract 4x, subtract 4x. And if you look, cancel, cancel, and I get negative 8 is equal to 1. So what that means right now is this is inconsistent. This is not going to work. This is not nice. So this is inconsistent. And what that means is no solutions. So that means you can't plug in a value of x to this equation and get the same thing on both sides of your equal sign. It's just never going to work. So let's look at this example over here. I still do my PCVNA procedure. I have parentheses, I have to distribute, so there's nothing to do on the left side, so I just rewrite it. Distribute your 3, so I have 3x minus 9 plus 2. Combine your like terms now. 2x and an x is 3x. Negative 6 and a negative 1 is a minus 7. 3x can't combine. Negative 9 and 2 though. That gives you negative 7, so I have 3x minus 7. If you look, I have the same thing on both sides of the equal sign, so I can automatically tell this is an identity. This is going to be an infinite amount of solutions. But let's see what happens if I take it one step further. If I say subtract 3x from both sides because I want to cancel out my x term, these both cancel, and I am left with negative 7 equals negative 7. So since I have the same thing each time, I'm going to say it's an identity. So this has an infinite amount of solutions. So infinite amount of solutions. And what that means is you can plug in any value of x and you're going to get the same thing on both sides of the equal sign. So you can plug in 2, you can plug in 3, you can plug in pi, you can even plug in negative 1 million and you'll still get the same thing. So that is our next day of solving equations. If you have any questions, see me after class. Have a great day.